My name is Bruce Momjian. It's wonderful to be here again at HighLoad. My history of HighLoad goes all the way back to, I think, 2007, thank you very much. It was the original one next to Church of the Savior. And I remember Nikolai helping me there, and sightseeing we did, and it was a lot of fun. And I've been to a lot of them since then. But it's always amazingly great to be back. My name is Bruce Momjian. I am one of the Postgres core team members. I've been working with Postgres for 22 years. I am on a 27-day trip. So from here I go to Krasnoyarsk and Nizhny Novgorod, and then I go home. So I have about 10 days left. This talk is a very unusual talk for me. I go to about 50 events a year, and this talk has become very popular because it's not your typical, here's the Postgres technology, here's how to use it, or here's how to get away from Oracle, which was the previous speaker. It's more of a strategy talk, more of a thinking talk, more of a talk to help you understand where the database industry is going in the future. And my goal is to kind of help you to think back about some of the history that you've had with software over the years. Of course, my involvement with computers goes back about 30 years. And perhaps to help you see the history of software and the evolution of where software is going a little differently. Of course, I'll talk about Postgres as we go, but there is a much broader concept here that I'd like to cover. I will also say that there are one or two depressing things about this talk. I'll point that slide out to you, but the reason it's a little depressing is because when you start to think of some of the software that is no longer produced, that used to be great and isn't anymore around. And it's a little sad. So what are we going to be talking about for the next 50 minutes? First, we're going to talk about the concept of forever. I have to admit, when somebody suggested this title to me, EnterpriseDB marketing, I've been working for EnterpriseDB for 12 years, and somebody at EnterpriseDB said, you should do a talk about Postgres will live forever. I'm like, forever? Are you kidding? Like, what kind of stupid topic is that? But you know, the more I thought about it, and they said, you know, you could talk about this, and I've heard you talk about that. And then I was like, okay, yeah. And 50 slides later, I have a talk. So it's kind of interesting. Somebody suggests a topic that sounds completely crazy, and it actually ends up being a great talk. We're going to talk about the life cycle of software, both proprietary and open source, and I think this is one of the most interesting parts of the talk. Then we'll talk about open source adoption. I think this will be very helpful for people thinking about moving to open source, or you've already moved to open source and you need to convince somebody, or you just have moved to open source and you're trying to understand how is the landscape now different than when I was in proprietary software. There's quite a bit there. Section 4, we'll talk about Postgres innovation. Postgres is innovating very rapidly, and I'll cover that. And then finally talk about the community structure and conclude. And of course, we'll have time for questions. So kind of remember those questions. I was telling a gentleman before, every time I'd speak in Russia, the questions are very intense. So I'm looking forward to some good ones, and I'm sure you will not disappoint me. Forever. Okay, so what is forever? This is kind of a weird concept. I mean, the age of the universe, 13 billion years, age of the earth, 4 billion. Age of civilization, really tiny compared to age of any of those. The civilized period versus the age of the earth, again, tiny. Now, the digital era versus the earth is like near zero. So the idea that software is going to live forever is kind of ridiculous, right? But it doesn't mean can't last a long time. Just the concept of forever is really a stretch, because effectively the whole digital history started in 1804 with the first sort of programmable device, the Jacquard loom, then ENIAC in 1945 in Philadelphia, which is where I'm from. E.F. Codd, 1970, the dawn of relational theory. So we're probably, what, 48 years from the dawn of the relational era. System R at IBM, 74. Ingress out of University of California at Berkeley, 77. University-based Ingress, which is where Ingress started 32 years ago. Again, out of University of California at Berkeley. 1994, Postgres 95 sort of started as an open source distribution, and then 96, internet-based started. That's when I started, actually. So, concept of lasting forever, I don't know, but it'll last a long time. Here's another picture. How many of you have ever seen this device? Anybody? Oh, I got a 1. Okay, 2. Ooh, wow. Okay, so great. So when I was in high school in the 1970s, this was our computer. And when I say our computer, this was the computer in the school. I don't remember even the model number, but I saw this picture. I said, I gotta get this. So the bottom line is hardware doesn't live forever. So it's very rare to see these things still in production. Hardware wears out. Hardware becomes obsolete. It's very hard to modify hardware in place if you've ever tried it. So hardware, by definition, I would say, has a very limited life cycle in terms of how long it lives. Okay. Software, not so much. And I will admit right now, this is the depressing slide, okay? Because when you think back of a lot of the software that you used to love that was produced by companies, and you take this understanding of the proprietary business model, proprietary software business model, and understand it, it becomes kind of depressing. And I'm going to walk through it, but again, think back of some of the software that you used to use. So how does proprietary software get created? Well, the first idea is that there's some concept of innovation. There's some concept that we're going to produce some software that never existed before or fits a new need in the market. Okay? So because it's a proprietary company, there are people who are hired, and within a year, 18 months, maybe 2 years, they develop the first version of this proprietary piece of software. Okay? And once they've finished that first release, they go into stage 2. And stage 2 is market growth. So this is the opportunity for them to take their incredibly innovative piece of software and grow the market. And all of a sudden, it's selling like crazy. They've got a lot of orders flooding in. This is a very, very exciting time for the company. But at a certain point, you get to stage 3. And stage 3 is market saturation. For whatever reason, you've gone as far as you can with stage 2 and you've stopped growing. Maybe you control 90% of the market. Or maybe you control 30% of the market, and there's another 70% of the market that's dominated by some other piece of software, and you can't seem to really gain in that segment. Okay? So you've basically innovative, you've grown a company, you've grown a whole user base, but then you kind of get stuck. You've kind of gone as far as you can, and you really are having any kind of trouble gaining additional market. That's when you enter stage 4. And stage 4 is the most depressing part. Because there's so much excitement at stage 1, and there's so much excitement at stage 2. But when you get to stage 4, you've effectively gone as far as you can for the software. And you have to remember, people paid for stage 1. So somebody had to pay all those people to create the software in the first place, and they paid through stages 2 and 3 as you continue to improve the software and continue to grow your market to saturation. So you're basically sitting as the owner of the company or the shareholders of the company, and they're saying, well, we spent a lot of money to create this software. We paid all those people the first couple of years. It took us a couple more years to reach market. Now what do we do? Well, we should maximize profit because we spent a lot of money. We should get as much return on this investment as we can. And of course, you can't increase revenue. So how do you increase profit if you can't increase revenue? Well, obviously, revenue is profit is revenue minus cost. So if you can't increase profit through new revenue, how do you increase profit? Well, you reduce costs. and you cut costs to development, you cut costs to support, and this piece of software that originally was this amazing, exciting thing that took on the market and was this great thing, it's now kind of limping along as a fairly mundane piece of software that by the time it gets to stage 4 is really not doing anything exciting anymore. It's probably giving users a fairly poor experience because development's been cut, support has been cut in a lot of cases, and the company's just kind of coasting along. And the company's going to kind of coast along as they can until they reach stage 5. And in stage 5, they've effectively reached maintenance mode. So in maintenance mode, and we've all heard of software going into maintenance mode, okay, there's effectively no new features and innovation is effectively 0. All right? And the software will stay in stage 5 long enough, as long as those people can make money off the software through support, through upgrades for maybe new operating systems. How many times have you bought a new piece of software not because it did anything new, because you changed operating system and you need a new version just to work with your new operating system? And then finally, when they can't make money anymore, they reach stage 6, the software becomes end of life. And I find that kind of depressing when I think of some of the great software out there that I used. But it's really easy to see why proprietary software effectively is required to go through these depressing stages. And you know, if you think now of the software, proprietary software you may be using now, is it in stage 1? No, it's probably not. If you're using it in enterprise, is it in stage 4? Is it in stage 5? Like, you don't, right? I mean, so now, in a way, you have a number, actually, which kind of represents where that software is within the life cycle that normal proprietary software takes. Now, this may be a 3-year cycle, this may be a 30-year cycle, but they all seem to go through this stage, unless they're incredibly driven and an incredibly creative company. Okay. Open source has a different life cycle. And has a different life cycle. I've been asked to take questions at the end, so I'm sorry about that. Open source has a different life cycle. So in open source, you basically do not have the same forces, the same profit sources, the same revenue sources that you have in proprietary software. So you start out, effectively, open source often starts out as trying to achieve parity sometimes with a proprietary piece of software, whether it's an operating system or web server, a compiler, an editor, a middleware, a tool, a package, a game. Often they're starting in an environment that already has a proprietary player. We're going to be the open source player in that. Usually that's the way it is. Now, sometimes with some of the cloud stuff, it just starts out as open source. There never is a proprietary piece of software that matches it. Okay. Then stage 2, same as stage 2 in the previous one, you have market growth. Okay. And stage 3 is different. Effectively, at stage 3, you either innovate or you decline. But there's no sense that you are maximizing profit, because usually in open source there is no profit. There's no revenue, there's no licensing. The concept of finance is really controlling the development of the software really doesn't have the same effect. So you basically either continue to innovate or decline. And then you also have a stage 4, which is kind of interesting, where the source code is always available for somebody to continue. So even if the software declines, somebody else can come along and improve it. Now you might think that's a academic or a rare case, but in fact, when I got involved in Postgres in 1996, it was in decline. There was one individual supporting it. That person had a full-time job. The releases weren't being made regularly, and one of the reasons I got involved was to basically say, this is a very good piece of software. It has a lot of potential, but it needs leadership, it needs management, it needs somebody organizing everything, organizing everyone in a cooperative way so we can effectively improve this software. So the concept of number 4, which appears to be sort of a throwaway item, actually is important, particularly if you think of the life cycle of the software. So you might think that's all very theoretical, but I'm going to give you one example of probably the most unusual example I've ever heard of open source and proprietary software working together. How many have actually ever heard of Falcon 4? Okay, we got 1. 2. Thank you. So the history of Falcon 4 is really interesting. I'm not going to spend a lot of time on it. There is a Wikipedia article at the bottom if you want to understand detail. And in fact, I should have said that website right there at the bottom right is my website. So these slides are on my website. There's videos of my slides on my website. There's probably 20 or 30 PDFs on my website, all about Postgres, including this presentation, and videos of those presentations, and about 450 blog entries about Postgres. So if you're really interested, put my name in a search engine, go to that site, whatever. There's a lot of information there. I should have mentioned that earlier. Okay, so back here. So 1984, Spectrum Holobyte begins closed proprietary development of a game called Falcon. 1998, they released Falcon 4, which is the final version from a new company who bought Spectrum Holobyte called Microprose. 1999, Microprose ends development of Falcon 4. So you think this game is done, right? They've released version 4. They had a couple bug fix releases in there. I think it got to 9.08 or something. And like, okay, we're done. This is the end of game development for this project. In 2000, somebody leaks the source code of Falcon 4 for about a week. Long enough for somebody actually to get a copy of it. So a whole bunch of open source teams start to form around improving this game source code that was leaked. And in fact, it was designed to be very extendable, so it was a very logical thing for these other companies, so for these groups. So 2003, Benchmark Sims actually releases a community-modified version of this game. 2005, a company packages the Benchmark Sims open source changes and releases a new closed source version of Falcon called Allied Force. Lead Pursuit goes out of business, but Falcon is still popular. So in 2015, a website or a company called GOG.com, which I've never heard of before, republishes the CDs from Falcon 4 because on eBay, the Falcon 4 CDs are super expensive because everyone wants to run the BMS mods to play the new version of the game. And in 2015, actually the newest version came out. So this is a weird case where the software goes from closed source to open source to closed source again to open source again. And it gives you an idea when that source code is available that people can actually use it and make good use of it. A game that should have died or normally would have died in 1999 is still being developed today. Very interesting. To give you some graphics of how open source works and how proprietary works, this is the slide of proprietary development. If you've ever worked with proprietary software, and most of us have, and you've ever looked at the development process or looked at the feature set or tried to submit a bug report and get a fix, this is the incredibly inefficient way in which proprietary software is developed. You have a group on the left which represents the company, really controlling every level of development and design, testing, and so forth of that software. And then on the right, once the software is released, the users finally get to play with it. And then when they have a bug, it's got to go all the way back, and it goes back through sales or whatever. And then there's this incredibly complicated cycle, and very inefficient cycle. In contrast, open source has this process where the users and developers are always seeing what each one is doing. So users are always involved in our feature design, in patch review, in testing, in beta testing, in release, and even fixing bugs and reporting them. So the reason open source is able to produce software as good as billion-dollar companies with no money is this slide compared to that slide. Right? I know it looks very simplistic, but effectively it is that efficiency that makes all open source go. Another graph to give you a visual. When I started out with Postgres, that red line was below effectively closed source software. But the thing that I always realized is that even though we started out below closed source software, our line, the steepness at which we were improving reliability, improving performance, and adding features was much steeper than the closed source. So even when we start off lower, eventually, if you're steeper, you're going to cross. You're going to overtake that person, right? It doesn't matter how much of a lead you give somebody. If you're running faster than them, eventually you're going to catch up, and that's effectively what happened. Okay. Now you might think I'm just making this up, and oh, it's a Postgres person. He's just going to say wonderful things about Postgres or open source or whatever. Well. No, I'm happy to say bad things about Postgres if you want me to. I'm not hung up on that. But I do think there is something interesting here, and I can give you some example outside of the Postgres area. When I was a consultant in the 90s, the big enterprises were running these operating systems, right? They were running HPUX, AIX, and Solaris. HPUX actually was the one we used the most. Solaris was huge. But what happened effectively is that Linux went through that open source cycle. They started out trying to be an open source alternative to these operating systems, and they effectively innovated way beyond them. To the point where most of these operating systems, dare I say it, are in stage 4 or 5. Right? Like Solaris is in stage 6. It's not even in maintenance mode anymore, I don't think. So they stopped development in September last year, 2017, and I think it's in stage 6 if somebody wants to correct me. I think it's in stage 6. AIX and HPUX are probably in stage 4.5. Maybe they're adding a little bit of something. Okay. But that's sobering to me because they were the de facto standards when I was a consultant in the 90s. Right? How does this happen? How did Linux? Well, Linux went through that cycle I just talked to you. They went through they used that graph that had the lines straight across instead of the awkward, inefficient one that proprietary software has. Okay, and so. I don't know. Every time I gave this talk in Lisbon 2 weeks ago, and somebody came up to me and said, you really say some really bold things in your talk. Like, does anyone ever come up to you and like push back and say, well, that's really wrong? And I said, I keep waiting for that to happen, but it's like the 10th time I've given this talk, and I haven't gotten it yet. Maybe you'll be able to do it. We got some time at the end, but it is interesting. And again, as I promised at the beginning. My goal is not necessarily to sell you on any piece of software. My goal really is to help you understand the software industry and understand it in a different way than you did when you walked in the room. Okay. So let's go to databases. Well, I just picked the 6 that I consider to be the biggest. Certainly they were the biggest in the 1990s. Okay, we got Oracle at the top, DB2, Microsoft. Then the last group, Sybase, Informix, Ingress Corp, those are kind of stage 5. Informix might be stage 4.5. I think they're doing a little bit there. Ingress, I think, is maybe, I don't know, 5 or 6. And Sybase, they're down there somewhere in those numbers, right? So when I was doing consultant, they were like, I used Informix and Ingress all the time. I must spend 12 years using those databases, right? Those were the big ones. Now, if you look at Oracle, they're doing well, but I don't know. I thought these people were doing well. And they're not doing well right now. So I don't know how long are they going to do well? I don't know, right? But it is interesting if you've got operating systems which effectively have been superseded. Why would a database be different? I think it's taking longer to happen, but I do think it's probably inevitable. It's really interesting. One of the things, and I'll be coming back to this concept a little later, but one of the things that keeps coming up in terms of Postgres and a lot of open source, particularly Postgres though in the database market, is our ability to innovate in multiple directions at the same time. I mean, if you think of traditional proprietary databases, they can usually innovate in one direction at a time, or maybe two directions if you're lucky, right? But it's very hard because a company has to they all move together, right? And you have meetings, and oh, this is going to be our cloud release, and this is going to be our data warehouse release, and this is going to be our whatever release, right? They can usually go in like one, and it takes them a couple years too to kind of do this. With Postgres, because we're a distributed team, because we're kind of moving around all the time, we have teams all over the place working on independent things, we can innovate in multiple directions at the same time. So if you look at every release of Postgres, it comes out every year, probably 180 features in every release. You know, it's pretty impressive. There really is no other relational database innovating at the speed that we do. And we have innovations in ease of use, we have innovations in data warehouse, we have innovations in cloud, we have innovations in NoSQL, we have innovations in enterprise workloads, we have innovations in JSON and vertical scaling and performance and sharding and partition. I mean, just like all over the place when you look at those release notes, which I have written for several years now. It's overwhelming sometimes. And again, that's another reason I think that Postgres and other open source projects have been very popular. So, when does software die? Right? That's what this section was about. Proprietary software, depressingly, proprietary software dies when the owner of the source code can no longer profit from it. Sad but true. It declines long before death due to profit maximization. And I've talked about some of the sort of software in that stage 4 and 5 where the software is kind of limping along, but it doesn't excite anyone. Open source can't die in the same way because the software remains active. In fact, open source remains active while it serves a purpose. And it can be resurrected if useful. And in fact, in 1996, Postgres in a way was resurrected to give a new life. So it's not an academic thing. So to conclude this section, ideas or software doesn't die as long as it's shared. And ideas are shared as long as they're useful, so Postgres will live as long as it's useful. Is that going to be forever? I don't think so. Am I probably going to be doing this for another 20 years? I don't know, but I probably could. There's probably a lot of life left in what we're doing because we're continuing to innovate, and I'll get into that. One little story related to this, the concept of ideas not dying. I have 4 children. 3 of them have either gone through college or in college now, and in their freshman year or sophomore year, they come back from college, and we're sitting at the dinner table, and they say, they say, what did you think about Plato's Republic or Plato's cave allegory or the Symposium? And I'm thinking, wow, they still teach that. Like I learned that when I was, when I was in college or even in high school. And I'm thinking, well, Plato is 2,400 years ago or 2,600 years ago, and we're still talking about him. We're still talking about his ideas. Why is that? That's because what Plato said is still shared because his ideas are still useful. Okay? And in a way, software has the same effect. It's sort of an idea instantiated into some code, and those ideas, as long as they're useful, that's why Postgres, 32 years on, is still a very useful piece of software. Very little hardware is still around from 32 years ago, but Postgres and others are. So let's talk about open source adoption. We're going to get practical now. I've sort of given you the big philosophy talk and sort of helped you see the world differently. The concept of this section is really to talk about a survey that was done by Black Duck Software in 2016. So 2 years ago, Black Duck did a survey of their customers asking them about open source. Now, these are not people who are thinking about open source. These are people who have already chosen open source. Okay? And when he starts the survey, he basically says, 10 years ago when we started, we never could have imagined how pervasive open source would be. Of course, that they're certainly true. Again, you can read the slides later. But this, I think, is the real takeaway for me from this survey. There's 2 takeaways. And again, they asked people who are already using open source, what is the biggest advantage of open source to you? All right? What's number 5? Number 5 is cost. And if you went to those people, you said, when you chose open source software, what was the number 1 reason you chose it? They're going to say cost. Odds are most people consider open source software because of cost, particularly in the database area. But once they've chosen open source software and you go back to them a year or 2 later and you say, what advantages do you have? Cost is down number 5. Number 1 reason for open source is innovation. Because the open source software that they're using is innovating faster and giving them competitive features faster than the proprietary software they used to use. I go to probably 40 or 50 conferences a year, events a year, okay? And there's probably another 50 or 70 that I can't even go to, okay? And you know, nobody does that many conferences to save money. Like if you save money, okay, you save money, but that you're done. Like you're not gonna have 6 months later, you just, okay, save money. But if you're producing software that's innovative, that's giving people excitement, that's giving them new challenges and new abilities, that produces 100 conferences a year. And that's why Postgres is there, not for cost. Cost is great. Cost gets people to change because change is expensive, change is slow, change is painful. But once you make the change, the value you get is far exceeded by the cost you saved. Number 2, freedom from vendor lock-in. We're open source. We don't try and lock people in. Obviously, that's a great thing. Quality. Quality. That whole concept of how the open source does things, how we fix bugs, how we polish that software, much more efficient than a proprietary system. The ability to customize and fix a value. Number 5 is cost. Number 6, speed of application development. 7, development cost, more efficient. 8, interoperability, of course, one thing Postgres does really well. And finally, options, breadth of solutions. So again, for those who have already chosen open source, innovation is a huge, huge driver of that. And innovation is why they tell other people about it. If you save money, do you go to parties and say, hey, I saved money today? Well, yeah, not really. It's kind of, you're boring, right? I have a friend who does that. But anyway, it's some people are excited about it. But in general, if you're like, oh, I bought this new thing and I can now do these 20 new things that I couldn't do before. Look what I can do with my new chainsaw, right? You're like, wow, that's exciting, right? That excites people. And I'm not that Postgres is a chainsaw, but you get the idea, okay? Another quote from somebody basically saying that open source dominates operating systems, cloud, big data, Internet of Things, certainly mobile, huge, huge domination there, application tools as well, okay? 2015, they did the same survey. Databases weren't in the top 3. 2016, of course, databases became number 2. So sort of the dawn of the enterprise adoption of enterprise database, you can actually see this in the survey, okay? So what have we talked about? We talked about what forever is. We talked about open life cycle of open source proprietary software. And we talked about a survey that explained why people like to use open source and the value they find. This section, I just want to talk a little bit about Postgres innovation. I want to talk about why. Remember, in the previous set of slides, number 1 reason people who liked open source was innovation. So innovation is a key aspect to growth for open source software. And I want to just go through here and show you some of the innovative things we've done. Again, this isn't a technical talk. The slides are online if you want to get into more detail. So again, 1970, E.F. Codd develops relational theory. 1986, I'm sorry, Michael Stonebreaker starts University Postgres, and it was actually designed as an extendable system, extendable data types, extendable indexing methods, extendable languages, okay? This is the system tables for Postgres. Now, that might be kind of useless to you, but if you look in the yellow, there are some unusual things here. For example, every data type Postgres supports is in that yellow section. Every operator, the plus sign, the minus sign, the slash, the question mark, all these things are actually defined in the system tables. They are not hard-coded into the binary. We look them up in the system table. So if you want to add something, you add them to the system tables. Stored procedures. In blue, all the indexing methods, which our Russian friends have always been very fruitful in providing for us. We've had a long history of development in Russia, particularly in the extendability area, in the indexing area, and so forth. If you want to add a new data type to Postgres, you say create extension, you name that data type, and all of a sudden now I have 8 new data types that did not exist before. Okay? If you want to add a stored procedure language, we support these and more. All your favorite stored procedure languages are there. You just plug them in, just create extension in the name of the procedure language, and you're in. That's extendability, that's innovation. If you need indexing types, we support all of these indexing types. Again, many developed here in Russia. And a lot of these are specialized for innovative use of databases. The top one, Brin, used for data warehouse. The bottom, the middle one, Jin, is used for JSON. Gist is used for spatial and for full text search. So again, very innovative. I have a separate talk about non-relational Postgres, but this is just great stuff. Again, part of our innovation story. We have full text search built into Postgres, basically like a Sphinx or another one of those, but it's built in, so it uses standard SQL, it works within transactions, it's always synchronized, you don't have to have like synchronization, full transaction, everything there, okay? There's an example of looking for the word pandas inside of a thing, and you'll notice it's using a special index for that. We support NoSQL, again, another area of innovation. The NoSQL can be mixed with structured and unstructured data. We have specialized operators and functions and indexing, as I said before, and there's full transaction semantics. So here's an example for key first name, value Jane. I'd like to know the last name. Give me Jane's last name. I'm using JSON here. Okay. Range types. Range types are an ability to combine a start and a stop into a single field. Okay, again, standard index, specialized indexing for this, and fully transaction semantics. Here we're saying, give me the car rental that contains this time period, this date and time. Give me, and we're not just sequential scanning through the data, we're using specialized indexing to get it to that exact row. Geometric types, point, line, circle, part of what Postgres is. Here's an example. Give me the 2 closest points to the center. And we use an index for this. We don't just look at all the data and then sort through it. We have a special capability, again developed here in Russia, called nearest neighbor search. And we actually walk through the index to find the 2 points closest to the center without having to create like a box and then a bigger box until we get enough points. Very, very innovative. GIS, Geographic Information System. We have a GIS separate project called PostGIS, which is developed by a separate team, and they just plug into Postgres, again, as an extension. Again, part of our innovation. Here's an example. Okay. Foreign data wrappers, the ability to reach out to other data sources. I talked about interoperability. This is all part of the Postgres story. Okay, you can read right to Oracle data, you can read right to Mongo data, you can even read Twitter feeds if you wish. Data analytics, normally people would do data analytics in a separate server. In Postgres, you can do data analytics inside the database, right? This is all features we added in the past 5, 7, 8 years, doing data analytics inside the standard OLTP transactional engine. And you can run your data warehouse on a separate server if you wish, and do your primary read load on another one. And finally, sharding. This is the ability to do to take partitioning, parallelism, foreign data wrappers, logical replication, global transaction manager, and create a multi-node version of Postgres. We're still under development here, probably another year or two until we're production ready, but again, a new innovation step. So, to conclude, Postgres has been around a long time, 32 years. It's BSD licensed, so therefore it's available pretty much to do anything with, including create closed source products around it. The development and leadership are diversified geographically, culturally, and also a multi-company project. So no single group controls it. 32 years of development, 22 years of annual releases. Again, as I said, 180 features per major release. We release minor releases every quarter, and we are the most loved relational database. Yay. If you think I'm making this up, this is actually a website called PG Life. URL there at the bottom. And I actually maintain it, but it maintains itself. It shows the most recent email sent, the most recent tweet, the most recent event, the most recent blog, the most recent news item, the most recent commit, all the active versions, all the commits on those versions, whether we're in a commit fest or not. Like sometimes I'll just sit and I'll just look at it and I can see exactly what's going on. There's a lot of things going on. So that does finish my slides, but we've saved time for questions. And I know there's one gentleman over here, but I'm hoping some other people have questions as well. So I believe the gentleman is not here anymore, unfortunately. Is that correct? So who has the first question? Yes, sir. Yes. Of course.
Let me just cry here.
Oh, there we go. Here we go.
Okay, thanks.
Yay.
I want to ask you about the community. We have just saw a small slide with the people sitting in some room, and we saw some years of development. It's about 30 years, and it's about people scale. When some people came to Postgres on the start, when some others took it on a whole life and were powerful and were now contributing and controlling. And people life are not infinitive.
True.
So is it a problem for community and for the project and for all these startups who saw a lot of here, they try to contribute in Postgres, and Postgres are rather conservative, and it is good for now, but a lot of features are still not included.
Yeah, that is something that I think about a lot, because obviously, you know, I'm one of the core leaders, so we're trying to think we're looking very far away. So one of the values of having been with the project for as long as I have, and many of the other team members as well, is that we have a history of almost decades of involvement. So we know that we're getting older. You know, we know that we're certainly, as you said, not going to be here forever. So one of the things that we've been focusing on is to bring in new people and to encourage new people. One of the real strengths, I think, to the community is that when we're discussing features within the community, there really is not a whole lot of favor given to long-term people versus new people. So if you think of the Linux kernel, for example, the whole structure of the Linux kernel development is very hierarchical. You have Linus, and then you have lieutenants, and then you have, right? So it's this pyramid of, and somebody coming in new, they're kind of coming in at the bottom, and they're looking up and saying, oh, I'm here, right? And
Linus and not Linus.
Right. So one of the things I realized early on is that, you know, I'm good in a small group. But when you put my skills up against the rest of the world, like I'm really bad. So like, I don't know, you might be great in your company, but when you start to compete against people in the entire world, like you're not that good, and I'm not that good. Because people, there's so many ideas in the world that I would never even think of. So one of the structures we have is to say, when we're talking about a feature, or we're talking about adding something, or a bug fix, or whatever, anyone can pretty much say anything, and that new person is just as valid to make a suggestion as an old person. So I am regularly having to defend my opinion on something, and a lot of times I'm wrong and I lose, you know, and then Tom Lane loses, and then we all lose. And some new person has an idea that we didn't think of, and we're like, oh, that's a better idea, we're just gonna go do that. So as leadership, one of the things that I'm always trying to do is to encourage people who are new to say, oh, that's a great idea, I'm glad you made that comment. I may do that privately. They may be their first email, and I'll privately say, hey, you really made a good point in that email, and I'm hopeful we can, you know, fix it or add whatever you want or whatever. Probably the other thing you're pointing out is that it is a conservative community because it's a relational database. And we have a lot of people who come in who say, oh, let's do this and let's do that, which may be good, but we've been at this for 22 years. So when we do something, we have to live with that change for another 20 years. And therefore, people who are coming in who just want to, I just want to do a quick thing and I want to leave, right? That doesn't work well, because a lot of times the first version of their fix would be fine if we only needed to live with it for 6 months. But because that code is going to sit there for decades, they have to spend time to make sure that code is exactly, that it works perfectly within every other system that Postgres has. So a lot of the pushback we get from new people is, I just want to do this little thing, and we're like, okay, I understand that, but you have to consider the whole system and the life of the system, and you're going to have to spend a lot more time to add this thing, because there are many places that are going to be affected by it, and we have to make sure every single one is perfect before we apply that patch. And that is frustrating, particularly to new people who are used to just continuous development, you know, DevOps, we'll just keep pushing out the code. Well, we're a database. We can't just push out new versions of the database and hope to get it right once. We've got to do it right every time. It's because one of the different things about databases is, a normal application, it doesn't have a state. So if your application dies, you just restart it, right? But database, by definition, has a state, and it preserves that state and reproduces that state at some later time. So we don't have the luxury of making mistakes. And people who are not familiar with that environment think that Postgres is slow to adopt new things, and we are. But it's not because we don't want it. It's because a relational database has a requirement that limits how quickly, or how it requires a tremendous amount of detail to do anything. It's sort of like working in a nuclear missile silo. You know, I've done studies on that. Like, everything has to be checked. Everything's a checklist because you're a nuclear missile silo. Well, we're not a nuclear missile silo, but we have a lot more requirements on us than the typical piece of software that people work with. Other questions? Yes.
Hi, thanks for the talk. Something a little bit unrelated to Postgres, but you mentioned open source versus proprietary. I think we see right now two big trends, right? A lot of trends go to open source, like for example, Kubernetes as a next layer. Everybody agreed on Linux kernel. Now maybe everybody agrees on the next layer, and so we move up the stack. But we also see another trend towards SaaS software. And how do you see this in relation? And one prime example is GitHub.com, right? The prime open source company is not even open source, right? It's not actually open source company. So, because this is like also the question, how long does software live? If it's SaaS, it can be turned off at any time. So,
yeah, we've had people push back on us, particularly cloud deployments of Postgres. Some of those cloud providers are not as engaged with the community as you would hope. So I'm hoping that over time the cloud providers will start to take an investment, start to think of open source as an investment that's part of what they need to do. I think we're still early on that, but you're absolutely right that when you're relying on a cloud provider, particularly if they've modified the database, which Amazon does, for example, then particularly Aurora, which is even more modified. But the problem is when they modify it, then you don't have, that's not really open source anymore, and you're kind of, if they shut it off, then your data's gone and your data's gone and your database is gone and your data's gone at the same time. Serious problem. So obviously we're going to want to have some backups that are local, but also, yeah, I've never really thought of that. It's something I have to think about. I can see it as ending pretty badly. Yeah. Other questions? Yeah, I think I'll have only one more and then we'll have to stop. Thank you.
Please stand up.
Okay, stand up. So what aspect of like Postgres system do you think needs the most love? What aspect do you think is in terms of like targeting the state-of-the-art systems like SQL Server, what aspect of Postgres do you think is the farthest behind from achieving parity with the commercial guys?
Well, for SQL Server, probably it's the user interface, the administrative interface, or SQL Server's done a very good job of giving you sort of a Windows API, like a Windows GUI management API to the database. We're probably never going to be there. Because they're tied into their operating system they own. So that
like core database architecture.
Core database architecture, I don't think there's really much. I think, just to give you the short answer, I'd say up until 2 years ago, we were basically playing catch up in terms of feature set with a lot of the relational systems, particularly proprietary ones. I think past 2 years, we're now entering an innovation phase where Postgres is going beyond what they do. And it's not really a question of, oh, are we behind on stuff? It's like, how far are we ahead in all of these measures that these other people are never going to be at?
You don't think the Postgres optimizer is insufficient?
I do not.
Okay.
Okay. So unfortunately, that's all the time I have. So
Thanks
I'll be
for
here
your
if you have questions.
presentation.
Thank you.
Thank you for your question.